Today we are starting Unit 8, and we are going to first talk about polynomial inequalities. And so what we're going to be using in order to solve a polynomial inequality is a sign chart. So you may have seen these before. If you haven't, just hang tight and I'll show you how to do it. Here's your essential question. How do I solve polynomial inequalities using a sign chart? Okay, so this is our first example. We have x squared minus 4x minus 12 is less than or equal to 0. So what we're looking for here is we want to know, where is this graph, basically where is it negative? Okay, so in order to figure that out, we could use our calculator or graph this function and then figure out where is it below the x-axis. But if you don't have a calculator and you do need to know the behavior at that point on the graph, we can go ahead and use what's called a sign chart. So the first thing that we are going to do here is factor so we can find the zeros. So if I factored this out, you could use your x, you can use your box, however you feel about that. But we're looking for the factors of negative 12 that add up to be negative 4, and that happens to be negative 6 and positive 2. So I factored that left side. We did keep this side equal to 0, so we make sure that that one side is equal to 0, we factor the other side. So now I know that I have zeros at positive 6 and negative 2. This is just like what we did in the last unit. You set each factor equal to 0, and then that would be what your answer is for that x-intercept. So I'm going to go ahead and I'm going to set up my sign chart. So my sign chart is going to have a negative 2 and a 6 on it. Again, we're writing our zeros on this number line in order for us to kind of figure out what's going to happen. Because the only way for my graph to become negative is it needs to go from above the x-axis to below the x-axis or vice versa, and to do that it's got to cross through a 0. So these guys right here, we've got to figure out, did it cross going up and then going back down, or what did it do? So we're going to go ahead and pick some test points for this. Now these test points can be whatever number you feel like. I tend to try to pick ones that are close to the number that's right there, or like a 0 or something easier to figure out. So I'm going to pick a test point, and I'm going to pick negative 3. Okay, so that number is to the left of negative 2, and if I plug it into this original equation, I want to know what sign my answer is. I don't really care what my answer is, I just want to know if it's positive or negative. So I'm going to go ahead and plug it in the factored form. If I did negative 3 minus 6, I would get a negative. And if I did negative 3 plus 2, I would also get a negative. So we know that a negative times a negative is a positive. So over here on this part of my graph, I would have positive. Okay, and then I go and I do the other parts. So I pick a number in between negative 2 and 6. The easiest one I can think of is 0. And again, plug it in. I would get a negative, and I would get a positive, and negative times a positive is going to give you a negative. Okay, and then I finally pick one that's over here, and you can pick something big. You could pick like 10, and I would have a positive number and then a positive number, because I'd have 4 and I'd have 12, and that would get me a positive answer. So that's what my sign chart would look like. So at this point, I need to go look and see, where is my graph negative, because if it's less than 0, it fits the criteria of this problem. And so I know that my graph is going to be negative in this section right here. So I'm going to write that as an interval. So we'd have negative 2 to 6, and then I have that equal to, so I can use those square brackets. Okay, and so that would be your answer. You want to know, where is it negative? So all you're doing is pick a number, you're looking in there, and I mean, if we had graphed this function and used those zeros to graph this function, we would have seen the same thing. We would have had this kind of shape, and we care about this little section down here, which would have happened in between negative 2 and 6. Okay, let's do a couple more examples. Okay, so we have x squared plus x plus 3 is greater than 5. First thing we have to do is get this thing equal to 0. Otherwise, we can't do what I just did in factor and set the factors equal to 0. So if I subtract 5 from both sides, this is going to be my new function, and again, you have to have 0 on one side. Factor this new expression. The factors of negative 2 that add up to positive 1 are going to be positive 2 and negative 1. I go, wow, struggling. I go ahead and I'm going to write those zeros on my sign chart. So I know that I would have zeros at negative 2, and I would have a 0 at positive 1. And then I just go ahead and I pick some test points again. And so a good test point maybe is -4. So if I plug that in over here, I'd have a negative and a negative, which again gets me a positive. Okay, then if I plug in something in between like 0, that's a great one. I'd have positive and negative, which would get me a negative. And then finally a number bigger than 1, so 2, I'd have +4 and +1, so I'd be left with a positive. So that's what my sign chart would look like. I go back to what my question's asking me, and this one says I want it to be bigger than 0. So I want every place where it's positive. So I'm going to go ahead and write this out using interval notation. So I know that this number line continues going on that way. So I'm going to start from -infinity, and then I stop at that 0, at -2. Now the one thing here is there's no equal to underneath, so I'm going to use the parentheses and not the square bracket, because I can't equal to 0 in this case, so I want to make sure that I use the not equal to bracket. Okay, then I look, and on my sign chart I have one other place where I have positive. Starts at 1, so I'm going to just say union. And again, we can't equal to 1 because there's no equal to, and then it goes on forever that direction, so towards infinity. So those are places on my graph that would be bigger than that number. Okay, the last one, and it's probably one of the most tricky ones you'll see, looks like this guy. We have x cubed minus 2x squared plus x is less than or equal to 0. Again, your first step is always going to be to try to factor these things. The first thing I notice is that there is a GCF in there. They each have an x. So I'm going to go ahead and take out an x from every term, and then see if I can factor that inside. And I can. That's actually going to be a square. So right here, I think of the factors of +1 that add up to -2, and that would get me x minus 1 times x minus 1, or x minus 1 quantity squared. Okay? And so then I think about my zeros and I set them on my sign chart. I have x equals to 0, so that would just be 0 on my sign chart. And then I would have x equal to 1. And I only have to put it there once because it would give me the same thing either way. Okay? So I'm going to go ahead and do some numbers in here. So if I pick like -1 over on this side, that's going to get me a negative times a negative times a negative. So if you get 3 negatives, if you have an odd number of negatives, then you know that you would have a negative answer then for a product. Okay? Then I pick a number in between 0 and 1, so probably like 1/2. So I'd have +1/2, I'd have 1/2 minus 1, so that'd be negative, and then another 1. So that would make this whole answer into a positive, because you have negative times negative, and then a positive. Okay? And then finally, if I pick a number bigger than 1, so like 2, I have positive, positive, positive. So this is all positive. Okay, so I'm going to go ahead and look and see what they want from me. They wanted this expression to be less than, so they wanted it to be negative. So I have one of my intervals here where I have it going from -infinity to 0, and I can put a square bracket around 0 because there's a line underneath. Okay, and you might think that you are done at this point, but there's one funky thing happening here, and that's the fact that I can have my function equal to 0. And we said before that this 1 is actually a 0 of the function. So this section fits my criteria, including the 0, but I also have to include the +1 in this because that makes that statement true. So I'm just going to go ahead and write union and put in that 1 in square brackets to say it's all of these numbers and then 1 as well. And that's all I've got for you today. Pretty straightforward. You might have seen this before. I will see you tomorrow and we'll practice solving polynomial inequalities.